In this problem, we're going to determine how many possible ways you can distribute 5 different presents to 4 children. And it's not required that every child gets something. You could have one child get all 5 presents. You could have 3 children get 1 present and 1 child get 2 presents. There's many possible ways you could distribute these 5 different presents to 4 children, and we're going to count the number of different ways if there's no restrictions on how you distribute them. All right, so to get started, what we should do is first define some variables. Let's see, let's say presents. Presents, we're going to have presents P1, P2, P3, P4, and P5. And children, our children will have A, B, C, and D. How about the children are Alice, Bob, Carl, and Danny. That's why they do that in Calc 2 or in Calc 1 when you have Alice, Bob, Carl, and Danny. It's because it's A, B, C, D. Anyway, I digress. Let's see. Okay, so let me show you the correct way to do it, and then I'll show you an incorrect way to do it, and we'll see, and I'll want to point out why it doesn't work for the incorrect way. Okay, so the correct way to do this is to make the positions to fill the presents. Okay, so we're going to have 5 positions to fill. Say P1, P2, P3, P4, P5. So 5 positions. 5 positions. Okay, and so the 5 positions are the 5 different presents. And think about it, right? You could have, let's say Alice, she gets presents 1 and 2. Then we would have, then one of the many distributions would be, let's give Alice presents 1 and 2. Bob gets present 3. Carl gets presents 4 and 5. And Danny, too bad for you. All right, there's one possible distribution of the presents. Let's see, another one. Let's see. Oh, let's just give them all to Alice, right? There's another possible distribution of presents. Right, many possible here, right? But the point is, right, is that for each of the different positions, in this case, the presents, we have 4 choices. 4 choices, 4 choices, 4 choices, and 4 choices. All right, and notice that whatever your choice is for one of the presents, it doesn't affect your choice for the next present. And you could say that your choices of the present, your choices of which child to put in one of the 5 positions is independent of the other choices of positions. Okay, and so the correct answer here is, right, we have 4 times 4 times 4 times 4 times 4, otherwise known as 4 to the 5th. Right, that's the correct way of doing it. All right, now Now let's look at an incorrect way. So an incorrect way of doing this, right, would be to make the children the positions. This is an incorrect way of doing it, okay? So now let's say that I awarded Alice 2 presents. Let's say I put 2 presents in there. Let's say I awarded her 2 presents. Then that will change how many presents I can award to Bob, right? If I award Alice with 3 presents, then that changes the number of possible presents that I can give to Bob. So this is an example of a situation where it's not where the number of presents that I give to Bob is dependent on the number of presents that I give to A. This is the opposite of independence. This is dependent. This is the answer for Bob is dependent on the answer for Alice. Right, so that's why this situation where you put the children as the positions doesn't work. And I realize I should have left this up there before, but anyway, I thought about this as I was erasing it before. So right, so this was the correct way, right? Where we had the presents be the positions. So here, like, notice that if I award, I give Alice present 1, that doesn't have any bearing whatsoever on which one of these 4 that I put into that position, right? So the choice of children, the choice of child for position for present 2 is independent of my choice of child for present 1.